So I will be attempting to reteach lesson 11.7, the use of geometric probability. Vocabulary is probably one of the hardest concepts to understand in this section, so let's start with that first. Some like to say probability can be shown in the forms of dice or maybe even cards, because probability is the measure of the likelihood that an event will occur. But geometric probability is a little different. It is a ratio that involves a geometric measure such as length or area. Since length probability is probably the hardest out of the two, I figured I'd give you an example first before we got to the fun stuff. It says, find the longest you can wait for a monorail and still get to the station near your work by 8:58. The ride takes 9 minutes, so you need to catch the monorail no later than 9 minutes before 8:58 or by 8:49. The longest you can wait is 3 minutes. So I've drawn the timeline that was in the book, and I also read that it says that the station monorail runs every 12 minutes, so that we need it to arrive in the first 3 minutes. So I've wrote it on our piece of paper that it needs to arrive in the first 3 minutes, and I've also written that our favorable waiting time would be 3 minutes, and our most waiting time would be 12, and that simplifies to 1/4 or 25%, which would be our probability that we could make it to the station by 8:58. So, my mom just came in the room and handed me this envelope. And it says, from the Hunger Games. I opened it and I read what's inside, and it said that I get to go stay on the Hunger Games set for one night and see just how Katniss lived. This is gonna be fun, guys. Let's go.
Happy Hunger Games, and may the odds be ever in your favor.
I'm here, guys! So they already put me through hair and makeup, and they're about to put me in my starting position. Here I am, guys, in my starting position.
3, 2, 1. Bong!
Tributes, listen, tributes. We have a care package for you waiting at the lake. I know some of you need it. We will see you there in an hour.
On the way to the lake, guys. Let's go. Finally safe. I want to try and figure out where Cato is. So do you think you guys can help me find the probability that Cato is in those trees over there? So we want to find out what is the probability that Cato is in those forests. So I've drawn a map of what the arena looks like. Here would be the lake, and here would be the forest or the trees. So we want to find out what is the probability that Cato is over here in the trees. So as you can see on the map, I've measured that from the beginning of the arena to the lake is about 1.5 miles, and from the beginning of the lake all the way over to the end of the forest is 4 miles, and then the width of the arena is 6 miles. So what we're going to do is we're going to start with the area of the forest. The area of the forest would be 4 minus 1.5 miles, which would be equal to 2.5 miles. Then find the area, or then multiply it by 6, which would be the width, and you get 15 miles squared. Don't forget your squared because you're dealing with area. After, find the area of the whole arena, which would be 6 times 4 equal to 24 miles squared. Again, don't forget your squared. And then divide 15 by 24, and you get 0.625, or 62.5% that Cato is in the forest. Okay, so now that my day's done at the Hunger Games set, I want to get home, but I don't know how. A taxi leaves every 5 minutes from the Hunger Games set, and it takes 12 minutes to get to my house from here. So, if a taxi leaves every 5 minutes, plus another 12, what's the probability that I'll make it home by 6 when it is 5:15 right now? Let's figure it out. So it's been a long day on the set, and I was really tired and really exhausted. So we know that a taxi leaves every 5 minutes, and it takes 12 minutes to get home from the set. So if we take 6 o'clock minus 12 minutes, it's equal to 5:48. And so we know that we cannot leave the set any later than 5:48. And so if you start setting up the timeline, 5 being right here, meaning the hour 5, and then you can leave at 5:15, 5:20, 5:25, 5:30, 5:35, 5:40, or 5:45, because you can't leave any later than that because they leave every 5 minutes. So I really want to be home kind of by 5:30, so it'll give me some time that I can take a shower and everything before my mom gets home. If I want to leave by 5:30, the favorable waiting that I want to do, or the favorable number of rides that I can take, would be 5:15, 5:20, 25, or 30. So we're going to put 4 over the total amount of rides that I could take, which would be 1, 2, 3, 4, 5, 6, 7. 4 out of 7 is the probability that I'll make it home in my favorable time. So that would be, if you tried and simplified, .57 or 57% that I'll make it home in my favorable time. I wanted to say a special thanks to my amazing friends, Kim and Sigrid. Thanks, guys.
You're welcome.